Now let's start our training. And this is the first training. The main topic for this training will be introduction of visual slope. And we plan to have a 40 minutes lecture and a 20 minutes question and answer. The introduction of the visual slope, including features of visual slope, input file format, and how does visual slope work. The second topic is modeling, which is the main topic today. The modeling method including drawing method for modeling and tracing method for modeling and AutoCAD's import method for modeling. And first we go to the introduction of visual slope. Visual slope currently contains 12 modules: slope stability analysis, soil nailing design, retaining wall pile design, MSE wall design, reinforced slope design, gravity retaining wall design, seepage analysis, and shoring design, tunnel lining design, freezing construction design, pile supported embankment design, and the 2D FEM. And the users may wonder, you have 12 different modules. Were those in the 12 separate programs, or they are in one program? Actually, they are just in one program. All the import file is just one format. So now let's look at the file format. You can see here are many different files for different projects, but they are all in one format. The extension is LSP file, and the size of the file is usually from 5K to 10K. So it is very small files, and it is a text file. And if you have any questions with import and as what you would do, you can always send the file to us, and we can take a look at that and correct your errors and send it back to you. If we open one of the file, and one of files, and we will see inside is a text file. And the first line tells you this file is created by which version. And the next two lines mainly give you the topics of this project. I just have one line, and you can put another line in. And followed by the units you are using for this project and other numbers, including soil properties, something like that. But users do not have to directly deal with those numbers. Visual slope is a graphic-driven program. This text file is from the graph you draw in, and so you don't have to worry about the file itself. Now, let's just open this particular file, and we go to Visual Slope, and then we open Visual Slope, and this is the front page of Visual Slope. And we can see there are new project and existing project. If it's existing project, most likely it will list here, but if it is not, you can always browse into it. Here we find this file, we open it. This project contains a dam which is consists of clay. If you right-click the mouse button, you will see it's clay. And behind the dam, there's a river. This is the water table of the river. Now, say if we want to run a slope stability on this dam, what we can do is we can just click that, and you can run a slope stability analysis. You can see the factor safety for slope stability is 3.34, which is under the condition the water has not gone to the dam yet. So the factor safety is 3.34. But for the same model, if we want to know how does the water will go into the dam and to the final stage, and the water level would be inside of the dam. So we can use a seepage analysis function to do that. So we run that, and we run a state seepage analysis. And you will see here's the result. If you click it, and you will see this is the water pressure, water head pressure inside of dam. And if you right click it, you will see for here P equals 0, which means the pressure is 0, and that means this area is unsaturated area. If you're going down a little bit, you will see there's a pressure there. So this is a saturated, started from a saturated area, and you can going down further, the pressure will be higher. And if you want to see more clearly, and you can use a contour, and you will see this is the contour. Above that is unsaturated zone, and below that is a saturated zone, which tells you in visual slope, you can use one model for different analysis. And if someone will say, if I want to see this then the slope stability analysis under the seepage condition, that you can do that. We just click this, and you run a slope stability again, and it's finished. It's very fast, and you will see the factor safety now is 2.2. Before was 3.3. The reason is now you consider the seepage pressure in the dam, and this is the failure surface. The factor safety is much lower now. So that tells us visual slope, you can use one model to do different analysis. You can also use different functions for one model, which means you don't have to buy many programs. You can just buy one program, and then they let it do it for you. It's just like a toolbox. You can grab a tool to work on something. So it's very easy to use. Okay, this is the introduction of a visual slope. Now we'll go to the main topic, modeling. Modeling including drawing method, tracing method, AutoCAD file import method, generating method. The generating method we will not discuss today. It will be in later sessions, like when we discuss about MSC wall design, tunnel lining design, then we will use the generating method. So let's first go drawing method. And the drawing method include the following steps. The first is material property. I think we should have a good habit. Every time when we try to establish a model or do some project, we need first import material properties. For example, like for this one, we will just have soil properties. For other projects, we may have like a tunnel lining properties, shoring properties, or MSE wall properties. But for the analysis, we always need to input the material property first. Then we can do the modeling. So the following are manual drawing method, coordinates import, length and angle import, coordinate correction method. So these are the different methods. Let's first look at the model we will establish today. It's a very simple one. It's a slope. It contains two different types of soil, hard clay and chip. And we know the coordinates of each corner. And then we will work on that. So first, let's open Visual Slope. Let's just go from the beginning. Open Visual Slope. And this is a new project. We just choose New. And then we click OK. Now this is the setting page. In that we can first give the title of this project. Let's say it's a slope stability analysis. And you can put the second line too. And choose the correct units for use. You can have meters, centimeters, feet, inches, but we choose meter for length. And for the force, you can have a kilonewton, kilogram, ton, pound, pounds. So we choose kilonewton. And now we need to give a dimension for analysis. Just how large the area you want set up the model. Let's just say right equals 0, and left equal to 0. I'm sorry. And right, we say it's a 110, and bottom is 100, and the top is 160. And that's the range you want to set up. But if you say, if I set up too big or too small, you can always come back to reset it. Or conveniently now, we can just amplify the model or reduce the model size. We'll show you later. So we go in, and then you are going to the main page of Visual Slope. If you want to change the setting, you can go to File and Settings and click Setting. The setting page will come back again. You can make changes. And we just go that. The first step is to set up a material properties. And we go to Material. The material includes soil, geograde, soil nail, MSE wall unit, tile, and beam. But so far, we don't have anything yet. So what we will do is we need to establish some new soil material property. We click this. This is the material button. Once you click the material button, the material page will show. And under that, you can see there's a different material type. For this one, we just need a soil material. Since there is no soil yet, so we just add a new. Once you click new, the setup page will show. You just put a name into it, the hard clay. And the density is 18, and the saturate density is 19. And the collision is 30. and the friction angle is 18 degrees. All right. And if we just for slope stability analysis, we just need those parameters. And you can put a different one if you need it. And there's a second page behind the first one. There's MSC wall settlement analysis. You can put consolidation data into it. If you for a seepage analysis, you need to put permeabilities in horizontal and vertical directions. And if you do a finite element analysis, you need a modulus and the Poisson's ratio. But for this one, we just need the first page data. Once it's finished, you click close, it closed, and you will see it's on the list here. And we can continue to do for the second material. However, Visual Slope has a database in which you can input your current soil data into the database for future use. Or you can use the database to pick up a material that you can use for this project. Say we want to have a shell. We just withdraw from the database to cut the project. But you have to check if the unit is a right one. By mute here, and you will see here there's something missing. So we have to correct that. So we just say this is 20, this is 21, and here we say it is 200. So we finish that. So we have two different material. First is a hard clay, which is green, and the second one is weathered shell, which is brown. But if you want to change the color, you click here and choose a different color, and say we want to have a yellow, then you can click yellow and click OK. And then this material will be yellow. When you close, you can see now we have two types of material, hard clay and shell. Once we finish the material property setup, we can start to draw the model. The models has soil, has a water table, and surcharge. Then let's first draw the soil model. And you will see that on the top there's a ruler which tells you the cursor position. There's a red hairline moving when I move my cursor. This is for the horizontal. And the same thing, you have a vertical ruler which tells you the current vertical coordinates. More accurately, you can see here at the lower left corner, there's a display that tells you the exact location of your cursor. All right. So let's first draw a soil line. We pick up soil line, click it, and you can see this is the cross here. And the first point is horizontal is 20, vertical is 120. So we just move to 20 and 120, and we will click it. Then the line stopped. And some will say when you click that, it may not exactly as 20 and 120. I want to be more accurate, so we can use the data input method. You can say next point is 40 and 120. You type 40, you can see in the yellow box there's a 40, and then use a space and then type 120. So vertical and horizontal and vertical coordinates will separate it by a space, and then you hit enter. So this point is 40 and 120. You can do the same thing. The next one is 60 and 145, 145, and you hit enter. Then this is next point. And it also can be imported with the length and angles. For example, this line, the next line would be, the length would be 20, and it's horizontal. So the horizontal line, the angle respect to the horizontal line is 0 degree. We use a less symbol, that's like a less symbol than 0. So it's a length separated by less than and 0, this angle. You hit it. So this is the line. And I will do it a little bit differently. I just do it very casual. I just finish that. And I don't know if the coordinate is right or not, but I'm not worried about right now. To finish drawing, you can click the right button of the mouse, and it will stop. Or you push the escape key will also stop. It's similar to AutoCAD. The next one, we just draw, say, the one like that. And you can see the red box, it will snap this point on. So now I have a rough model, but maybe the coordinates not that accurate. I can always edit the point. I click it, and the first one should be 20 and 120. We can just click that, and this is 20 and 120. This should be, I do not want to do the line yet. So this should be 60 and 120. And this one was right. And this one, we should have a 105 and 145. So you click that, and now the model is completely correct. And you can also, we need also have the boundary of that. You can draw the boundary one by one, but the fast way is just use the quick boundary. So this is the quick boundary. You already have the model established. But you will wonder if there's something I made a mistake, how do I correct it? How do I edit it? So I will show you that. If you want to delete a line, you can use this group selection. You can select this one, select that one, say then you click the right button. This table gives you different actions you want to take. For example, if I want to delete these two lines, you say delete, and they will ask you to confirm. You say yes. So, but those two lines will be deleted. But if we don't, we can always recover that. And you can also use this, choose an individual line. This individual line will show, and it will show the coordinates of this line. And you can change the coordinates there. You can also delete it there. If you want to delete it, this line will be deleted. But we do not want to delete it. We just put it back in. So this is the way to edit the lines. And we can continue to draw, say, the water table. Start here. Of course, you can import the coordinates, make it more accurate. I just don't want to show. But if it's a horizontal line, you can always click this button. And this will let you only draw horizontal or vertical lines if I draw a horizontal line. The next line, I do not want to be orthogonal. I want to be a lean one. Turn this off. You go this way. And this is the water table. And the next line is horizontal. We go horizontal. Okay, so finish that. The same thing, you can draw for surcharge from here to here. This is the surcharge. To set up a surcharge intensity, you click on the surcharge, and there's a load. You choose that, and now you can put a live load, dead load. So this is a 10, and the dead load is 20. So now you already specify the intensity of the load. And after that, you can put the material into it, and you can put that. So now the model has been established. You can save it, going to File, Save. Besides that, I want to tell you some tools that you can use in modeling. For example, if you want to reduce the model, make it smaller, and you can roll mouse button backward. So once you roll that, it will become smaller and smaller. And you can also amplify it by roll forward. That is. And you can, if you want to zoom into one specific area, you can use the zoom in button, and you can zoom in it. And this is, you can zoom this out by click the zoom out button. And you can also move the model up, and also the sideways, and also the diagonal. So you can move wherever you want to. And I already tell you, you can use the arrow to edit the coordinates. There's another useful tool is you can type some remarks to help you to read this model. Say 20 meter. I want to type 20 meter, and then you click this and then move this 20 meter here. So it means, and you can use this line. Try to say this is 20 meter. So now you have remarks on your model. It will be help you for read it. And when you save that, this remarks will be saved. The next time you open it, it will still be there. When you print, it will be in the print. And you can also say, if I want to choose this point, and this is the coordinate. If you click OK, copy, and you will see, turn it off, you will see this number is already in this box, and you can move that to here, so you know this coordinate is 60 and 120. So it gives you some tools to remark the model. So this is the drawing method for modeling. And following, we will see like some problems in modeling. How do we deal with those problems? For example, let me just open a file. This one. You will see there are 4 boxes. And the most problem we have in modeling is when we try to assign the material to one area. Sometimes you will find you cannot assign it on. For example, we have 4 diamonds here. That's just, I try to do the first one. I sign it in very quickly. I tell you how visual slope works. When you assign the material, you click here. The program will look up and find a line. And once it finds the line, it will go crosswise and find the point and find any line connects to that point. We find the two lines here, and it will pick a line more close to this one. So once we find this line, we'll continue to go on and find the next line, which can be this one and that one. It still go to the clockwise. So it will find this one and this one and find this one and continue and eventually come to this point. If this is a closed polygon, then the material can be signed. The next one, we click it, we find it cannot be signed on. The reason is when you hit that, it finds a line on the top and then search and find this line is more close to it. And this line is not a complete line connect to anyone, it's a dead end. So once it stops here, it cannot be signed material on it. So once we delete that, let's delete this line, see if we can. All right, so we deleted this line and we will see if we can sign that on. We can sign that on. So that's the problem solved. Next one, see if we can sign on. Yes, we can. And but be careful. Sometimes there's a line, and this is the line. They are not connect to the end, but they connect to the middle of the line. In that case, it may not be able to sign on. The following diamond, we cannot, because here is a open corner. So we need to close this corner. What we do is we highlight this and say connect the points. Once it's connected, then we can sign the material to it. So that's the something I need to mention to you, so you know once you have a problem, how do you solve that? And now we continue on. We discussed about the drawing method, and now we do the tracing method. Tracing method is like if we have, say this is a boring profile, and we want to establish a model based on this drawing, but we do not have a digital file. We only have a drawing, and but we can we can measure this out and find the coordinates and do the drawing method. But more easily, we can just input this file into Visual Slope and then just trace it. See, how do I do that? Let me just open Visual Slope again. And we say this is a new project. And or we can just say cancel. It will go into the main page. And in the main page, we're going to generators. And this is image tracing. Click this button. And then image tracing page will show on the upper left corner. Let's input an image. And we find this image. We import in. You can see this one is in. But you may notice the scale of the drawing is skewed because it tried to fit into Visual Slope screen. That is fine. We will tell you how to eventually correct that. So with this image, we can start to draw. We just use the soil line and follow that, and we can trace it. And how accurate you want to trace, and you can do very small portion one by one, or if you don't mind, if I just want to demonstrate that for you. I do pretty fast, pretty rough, but the skill will be faster than you measured out from a drawing and go by that. And you can see this is the top of slope. It's very easy to just draw in. And we can do the same thing for the top of rock. Here is the top of rock. Someone say maybe this method is not that accurate. I would say it's pretty accurate because you use the top line is only measured from field, and you pick up one cross section, and the survey may not actually use that section. And plus, if the slope only has like 10 centimeter difference, that will determine the slope is stable or failing. Then this slope is not that stable anyway. Especially for the top of the rock, you mainly based on the boring hit that. So you only have a few points in between. You just interpret that. So I would just draw that. Once you finish, you can also put the boundary around. So I have a basic model, but the scale is not accurate. So to make it accurate, I need to calibrate that. So what you need to do is measure the profile. Once you measure the profile, if you know two correct points, say this is the one point I know the true coordinate. You will draw that. And the next one, if I know that. So I draw a line. Once I have this line, I can type the true coordinate into it. The start point horizontal is 100, and vertical is 490. And the end point, start point horizontal is 700, and vertical is 596. Once you finish that, you click rescale and exit, and you will see now this cross section is on scale now. And so you can, if you have material property, you can put it in, and if you have a water table, you can draw in, or you can just trace the water table as trace the soil, the same thing. So basically, this is the way how do you do using a tracing method to establish a model. Okay, we are kind of the time is very tight, so I will continue on for the AutoCAD's input method. For myself, I do not recommend use AutoCAD's input method. I will show you why. But if you really want to, the AutoCAD file must have some restriction or requirement. The sections must contain lines or polylines. The other lines will be ignored by visual slope. The output file should be XF 2000 or earlier, because AutoCAD keep changing their DXF5 format. But just for consistent, we choose 2000 and or earlier. And after you input, you need to do lots of revisions and rescale. So now let's just give an example. Say this is AutoCAD file. It's similar to the first one we did. Now let's input that file into Visual Slope, see what happens. We open Visual Slope, and we just choose cancel. It's going to the main page of Visual Slope. And now we go to Find and Setting. Here, there's a DXF in. We click this button, and it will ask you if you want to save change. You say no. Now we find you can browse to a DXF file. Here's a DXF file, and we open it. And you can see this is the file we open. But before you do any change, and you need to turn off this connection button. The reason is once AutoCAD file input, every line is considered a soil line. Actually, we have a boundary line, we have a water table. For the soil line, if you do not turn off the connection, it will connect point to point. For example, here, it will break it up and connect to the point. But for soil, it's okay. But if for water, we do not want to break this, so we just turn this off for now. And first, we need to change the line type. So by doing this, we choose multiple selection. Okay. Once you select those, you can change that to boundary, and then say yes. So this will become boundary line. And the same thing, we can do it for water. So water, water, water. And then you click it and change that to water. And then click OK. So this is the water line. But if you try to do that, and now we can connect that. And now we try to input some file. And let's just say we give some material just for demonstration purpose. I get two types of materials: hot clay and shell. And we have those, and we have two types of material. And when you put that in, you see you cannot put it in. And the same thing for that. And the reason is here there's opening. In AutoCAD, sometimes even though you see it's connected, but actually the coordinates is different. And Visual Studio will tolerate if it's very close, but it's a little far away, even though you cannot see by next air, you still cannot sign the material property. So we need to connect those. Connect these 2 points. Connect. After you connect, you will see. You think you can assign. You still cannot. The reason is for this case. The reason is here. You see this is a line and a point. Actually, it is not actually connect to the point to point, but the point to line. So we want to connect that. Now it is connected. After that, I believe you can put the material in. Maybe this is still not quite connected. I would do it again. It's close, but it's still not quite connected. I want to connect. Now it's connected. So now you can put the material in, and this. So this is the model. But also when you click that, say here, you want to see that the coordinates, it's 4 and 12. Actually, we need 40 and 120. So AutoCAD make it 10 times smaller. So we have to rescale it. So there are 2 different ways you can do. The easy way you can do is going to here and do the scale. And in the scale, now it's one you type 10. I will multiply this by 10. So it will tells you this is 10. Okay, now it becomes this. And when you click that, you will see this is a 40 and a 120, even though it still looks smaller. And you can do that by zoom in. So now it becomes a real model, and you can put the soil property into it. And now this is the way you can use the AutoCAD input. So sometimes, many times, it's not that easy. You find the errors, probably you will spend more time to find errors instead of compared to your droid. So I would prefer just the droid. And also there's another one small trick you can use. Say here, if there's a point you want to move it, you can hold down your mouse button and then push it. It can move. Also, you can make it back. So this is the these are the three different ways of creating a visual slope model. So today we just discussed of those. And if you have any questions, and you can always send us an email. The email address is help@visualslope.com. The most time we will very promptly to respond your questions. Okay, thank you so much for attending this training, and I hope you will enjoy Visual Slope, and we will see you in the next class, which is slope stability analysis. Goodbye. Have a good night.